So we're still in Chapter 1, Lesson 1, but now we're moving on to Learning Objective B. So instead of talking about greatest common factors, we're going to go through the parts of the lesson that talk about least common multiples. So let's go through this first part together with the vocab. The least number that is a multiple of two or more whole numbers is the least common multiple of the numbers. Again, that's like a whole lot of stuff that we could break down to make it make more sense. So LCM, that's going to be what we use for least common multiple, kind of like GCF was greatest common factor. So let's write in least common multiple. And we're going to define what least is. Greatest was the most. It was the big stuff. So least is going to be the smallest. Common is the same thing. Oh, it's kind of a joke. So common means what is the same. And factor was the numbers that are multiplied together to get a number, but multiple is kind of different. It's like the opposite a little bit. A multiple is going to be the product, which would be more like the answer of a number multiplied by a whole number. So, for example, multiples of 5 would be 5, 10, 15, 20. And those are multiples of 5 because this would be 5 times 1, and this would be 5 times 2, and this would be 5 times 3, and this would be 5 times 4. 5 times 1, 5 times 2, 5 times 3 is 15, 5 times 4 is 20. So a multiple is the product of the number times a whole number. The product of the number times a whole number. So what we're going to do is we're going to say, okay, when we have two or more numbers, how do we find the least common multiple? For greatest common factor, let's turn the page. There were two methods, and let's read. This page is all about least common multiple. Let's find out how many methods there are on this side. Again, remember, a multiple of a number is the product of the number and any whole number. So these would be examples of whole numbers. Okay, you can find the least common multiple by using a number line, making a list, or using prime factors. So there are three methods for this. Method 1 is the number line, method 2 is an organized list, and method 3 is that factor tree, the prime factorization. So let's write in three methods. I am just going to give you an overview here. You're probably going to, this is like, again, the best in the end. It's a little bit tricky because it's a little bit different from this, so it's a little tricky, but I think a lot of you will like the list, and a lot of you that understand the tree will use it, and this takes so long to make a number line, I don't think anyone's going to use it. It's kind of the same thing as a list, but we're going to go through it anyway. So let's start writing here at the side. We're going to say LCM method 1 equals number line. And I'm going to write kind of small because we have three methods to put over here instead of two like on the other page. So the first thing that you have to do here is you have to make a number line. Make a number line. All right, so write that in. So as you can see, we're trying to find the least common multiple of 2 and 3, and the first thing that happened was you made a number line. Now it's tricky because you don't really know how far you're going to have to go up. Some of these number lines can go up into the hundreds, I'm not kidding. So yeah, that's why you might not want to make the number line. Number 2, so step 2 on this is you mark multiples on the line. Mark multiples. All right, so watch this. They used a red X to do multiples of 2. So 2, 4, 6, 8, 10, 12. They could have kept going, but they didn't need to because the blue X's were multiples of 3. 3, 6, 9, 12. So you mark the multiples. And then the final step would be circle the smallest multiple they have in common. So look at, they don't have any, oh, look at, they both have an x at 6. They also both have an x at 12, but remember we're looking for the least. So the smaller number between 6 and 12 is 6. So we're going to circle the smallest multiple they have in common. All right, so that's method 1, the number line, and there's the example of it right there. Now when we do the methods together in the guided and independent practice, I'm only going to show method 2 and 3, the list and the tree, just because the numbers get really big and the number lines are out of control. So let's move on to method 2, and let's write this in here. LCM method 2 is the list. And the first thing that you need to do in the list is you need to list multiples of each number. So it's just like when we did the greatest common factor, but we're listing multiples now. So list multiples for each number. You might find to do the higher number first, and the more you practice, the more you'll see why. But the higher number is going to be what the lower number has to catch up with, essentially. Let's take a look and see if I can explain that a little better with this example. So we're doing 2 and 3 again. We need to list multiples of 2 and multiples of 3. So we have 2, 4, 6, 8, 10, 12, 3, 6, 9, 12, 15. Now, again, I could have only listed 3 and 6 and 2, 4, 6, because as soon as I got to this 6, the smallest number they have in common, the smallest multiple they have in common is 6. So I could have just stopped my list right there and not gone any further, and you'll see us do that in the practice later on. So notice that 6 and 12 are common multiples, but 6 is the least. 6 is less than 12. So step 2, after you list the multiples of each number, is to just circle the smallest multiple they have in common. Okay, now I'm going to draw a line here because we're going to need this room to talk about the third method, which this factor tree is really similar to the tree here. It's just when you get to the end, there's a little difference. So in this one, let's write LCM method 3, and that's the factor tree. And the first thing that you have to do, just like with greatest common factor, is you need to break down numbers into prime factors. So break down numbers into prime factors. So let's take a look at that in the example here. We have 14 and 21, and 14 can break down into 7 times 2. Those are both prime. 21 can break into 7 times 3, and 7 and 3 are both prime. So the next thing you do is you circle any common prime factors. Circle any common prime factors. So 7 was common between these two numbers. It's circled. Now, here's where things get different, because over here, with greatest common factor, you just multiplied the common ones. Here, it's different. Number 3, what we're going to do is we're going to multiply all of these factors. 7, 2, 7, and 3. We're going to multiply all of them, but we're only using the common ones once. So let's write that down, and then I'll show you how to do it. So multiply all prime factors, but only use common ones once. All right, so check this out. We have 7 is the common one. We're just going to use that once. Then we have to use this 2, and we have to use this 3. So 7 times 2 is 14, and 14 times 3, let's see if that gives us 42. This would be 12. 3 times 1 is 3, plus 1 is 4, and that gave us 42. So 7 times 2 is 14. 14 times 3 is 42. So the least common multiple is 42. All right, now the next step is we're going to do these 3 together, and we're going to use the list and the tree way. We're not going to use the number line way, just because, like I said, it's tricky to draw out those number lines. You might as well just write it in a list. So we're going to do the list first. Let's list out the common multiples of 2 and 6, okay? Don't worry about room for the tree. We're going to do that a little differently. So right now, just make room for the list here. I'm going to draw a line in between these. Okay, so multiples of 2. I think I just said factors a minute ago, but we're talking multiples. Multiples of 2. 2, 4, 6, 8. But look I can stop at 6. Because even if I start to go up with this, 6, 12, 18, I don't even need to go up because the smallest one they have in common is 6. So I'm thinking our answer for this should be 6. Let's do this. Let's check it with the factor tree. Get a sticky note and let's make the tree here. So step 1 is break down into prime factors. So if I say this is E, F, and G. All right, so we have 2, that's already prime, and 6 can break down into 2 times 3. So we have these 3 numbers. Step 2, circle any common prime factors. So 2's are common. And then step 3, multiply all prime factors, only use common ones once. So the 2 I'm going to use once, and then I have to use this 3. And 2 times 3 is 6, and we got 6 here. So our answer is 6. The least common multiple of 2 and 6 is 6. All right, now let's do the least common multiple of 4, 5, and 10. So I have 4, 5, and 10, and I'm going to list the multiples. So I'm listing the multiples and stopping to circle the smallest multiple they have in common. So I might start with 10. Look, 10, 20, 30, 5, 10. That's common. 15, 20, 25. Okay, let's see what 4 does. 4, 8, 12, 16, 20. Ooh, there's a 20, 20, 20, 20. So 20 is likely going to be our least common multiple. Let's double check with the tree. We have 4. That breaks down into 2 times 2. We have 5, that's already prime. And we have 10, that breaks down into 2 times 5. So the next step was to circle common ones. So look at this. These 2 both have a 2, and these 2 both have a 5. So 2 and 5 are common. But we have to multiply all of them. So we use the 2 once and the 5 once, and we still have this 2 left over. Now notice they didn't all 3 have 2's and they didn't all 3 have 5's. That's okay. At least 2 of the numbers have to have it in common. Okay, so 2 times 5 is 10, and 10 times 2 is 20. 20, got 20 there. Our answer's 20 for the least common multiple there. All right, let's practice both methods, the list and the tree, and then when you get to the guided practice, you can pick one or the other. You don't have to do both. So let's list out the common multiples, or the multiples. They don't have to be common. 3, 6, 9, 12, 15. What about 5, 10, 15? Too bad 7 goes to 14. Then it's going to go to 21. Ooh, that's an issue. because this goes to 20. 28. 5 won't have a 28. It's going to have 25, 30, 35. Ooh, 35 is the next here. 14, 21, 28, 35. Man, maybe this will get to 35. Let's see. 15, 18, 21, 24, 27, 30, 33. Okay, do you see how this is like stinky? This is, it's going on forever. 36, 39, 42. Ooh, 45. That could get us somewhere because this goes 5, 10, 15, 20, 25, 30, 35, 40, 45. And this one, okay, what were we at? 7 times 2, 7 times 3, 7 times 4, 7 times 5, 7 times 6. Oh man, it goes to 48. This could go on forever. This is where I start to get an upset face and hate this method and say, hey, forget it. Let's go to the tree. So let's do the tree. Watch. Yuck. All right, we have 3. That's easy. That's already prime. We have 5. That's easy. That's already prime. We have 7. That's easy. That's already prime. So 3 times 5 times 7 gets us our answer. There's none in common. 3 times 5 is 15. 15 times 7, I need to work that out. I don't know. 35. 7 times 1 is 7. 8, 9, 105. So listen, I would have had to go up making a list all the way up to 105 if I used this method. So that's why I'm saying these tree methods, if you can use them, they are the best. So I would try to work hard to understand the tree methods because in the end, most people get the answer right if you use the tree. Okay, now there's a story problem. Remember how story problems for greatest common factor, you looked for the word greatest and most? Right here, greatest and most. There's a different keyword sequence that you're looking for. So flip to page 10. Let's do this last example. Ernesto has painting class every 2 weeks. Kamala has a pottery class every 5 weeks. Ernesto and Kamala met at the art building for class this week. How many weeks will it be until they see each other again? So he's coming every 2 weeks. She's not coming but for every 5 weeks. When will they see each other again? These are the key words you're looking for. Ready? You're looking for in the question where it's something like how many until this happens again? How many until they see each other again? That's the key word that you're looking for. You're going to see that again later, like down here. You're going to see these keywords in number 7 in the guided practice where it talks about how many movies before you get this again, this again situation. Before it repeats, that would be another word. So we're trying to find the least common multiple, and this is the list method. So 2, 4, 6, 8, 10, 5, 10. 10 is the least. If you would have done the tree, 2 is prime, 5 is already prime, 2 times 5 is 10. That would have been a lot less work than listing out all of those. So again, the tree method is pretty good. Okay, it's time to partner up. So let's see if your partner's in the same spot as you. If he or she isn't, let the teacher know and we'll help tell you what to do while you're waiting for your partner. But for the guided practice, I'm just going to move this because this was actually number 1 and 2. Sorry, number 1 and 2 from before. We're going to do 4, 5, and 7. So 4, 5, and 7. We're finding least common multiple. What I want you to do is work with your partner. Do number 4, then check it. Do number 5, then check it. Do number 7, then check it, which means you have to stop the video to do the work. Stop the video, then play it when you're ready to check it. Be sure to ask questions if you guys can't figure something out. You're going to look back at examples 3, 4, and 5 So look at these methods. You only have to use one method. You don't have to use both methods. So pick the method you want to use. All right, pause the video and do number 4. Okay, so if you do the list for number 4, if you do the list, you're going to have to list multiples of 7 and multiples of 9. Now, this is going to get a little yucky because you're going to have to go kind of far. 7, 14, 21, 28, 35. 7 times 6 is 42. 7 times 7 is 49. 7 times 8 is 56. Let's see what happens with 9. 9 times 1, 9 times 2, 9 times 3, 9 times 4, 9 times 5, 9 times 6. No, man, 9 times 7, 63. What about this? So 7 times 9 is 63. That's it right there. Now, just saying, if you do the factor tree, I'm going to get my sticky note out. If you do the factor tree for number 4, it would have been way easier. 7 is already prime, 9 is already prime. So 7 times 9 is 63. So the tree kind of wins on that one, just saying. Okay, what about number 5? We need to list, that's kind of in the way. We need to list factors of 6 and 15. And I'm thinking 15, it's probably going to be 30, right? Because 6 times 2, 6 times 3, 6 times 4, 6 times 5, so there's your 30. Now, number 5, you have 6 and you have 15. Let's break it down into prime factors. 3 and 5. These are in common, so those go here. We need the 2, we need the 5. 3 times 2 is 6. 6 times 5 is 30. So 30 is our answer. You get it each way. All right, now let's do the last one, that story problem down here. I'm going to kind of move these sticky notes. So it says the movie house gives away a $5 coupon for every 4 movies you purchase. They give away a bag of popcorn for every 3 movies purchased. So how many movies would you have to purchase in all before you get both a coupon and popcorn at the same purchase? So every 4 movies for the coupon, that's a trick. You don't even need that number. Every 3 movies for the popcorn, we need to find the least common multiple of 4 and 3. So let's make the list. 4, 8, 12, 16, 20, 3, 6, 9, 12. There's a common one. All right, what if you did the tree? I'm going to do the tree right here. 4 breaks down into 2 and 2. 3 is already prime. 2 times 2 times 3, they didn't have any in common. 2 times 2 times 3. 2 times 2 is 4. 4 times 3 is 12. So you would have to have 12 movies before you get the coupon and the popcorn. So pick a method or do a mix of both, but it's time to say thank you to your partner. Maybe give him or her a high five. Check the guided practice off your to-do list. And we need to do the independent practice for learning objective B. And that's going to be number 5 and 6 and 7. So you're just finding the least common multiple. Use whatever method you want to use. You're doing this on your own. So turn off the video, do these 3, and then check your work. Let the teacher or check in with your partner. Check in with someone if you have questions. If you're getting these wrong and you can't figure it out. All right, go for it. All right, I can walk you through these 5, 6, and 7. For least common multiple, here's the list, or actually this tree was probably a little faster. But basically, 5 is already prime, 2 and 3 are prime, nothing in common, multiply them all together. This list was actually pretty short here, listing out you only needed a few multiples, but here with the tree you had 3 in common, so it was 2 times the common 3 times 3. And this one was a little more intense. The list got long, so that was kind of intense, but this was also tricky. You had 2 in common. So 2 was here. These both had 2. All 3 of them had 3. And then the numbers that were left were 2 and 5. 2 and 5. So 2 times 3 is 6. 6 times 2 is 12. 12 times 5 is 60. All right, so we need to check the independent practice off your to-do list, and we're going to be moving into the reflection next. Again, check in with partner or teacher if you have questions on these. So this reflection, again, is supposed to be kind of like a little test to see where you're at after all of the lesson and guided practice and independent practice. Try not to use your book. It's set up very similar to the first reflection. So I can find the least common multiple of 2 or more numbers. Number 1, fill in the blank. I like to find the least common multiple of 2 or more numbers using the what method, number line list or factor tree. And for this method, I what? Describe what you do, so the steps for the method in complete sentences. And down here, do an example. Show how to do the least common multiple of 9 and 15. So whatever method you picked up here, go ahead and follow that method down here to find the least common multiple. All right, that's it. And then you're going to have the teacher check it and look at the board to see what to do when you're done.